When we build software, we're basically creating these little digital worlds. But how do programming languages actually build all the things inside them? Well, it turns out there are two really different philosophies for doing this. Today, we're going to break down the difference between classes and prototypes.
So, to get our heads around this, let's just start with a simple question. How does programming even try to copy the real world? Well, a lot of the time, programmers look right at everyday life for clues, because the way we naturally organize things is a fantastic model for how to organize code.
And think about it, one of the most basic things we do as humans is group stuff together. We're just wired that way, right? It's how we make sense of everything. We don't see every single chair or every single tree as a totally unique thing. Our brains just automatically slot them into groups.
Okay, take these two, for example, a hummingbird and an eagle. At first glance, they couldn't be more different. One is teeny tiny, its wings are just a blur. The other is this huge, soaring predator.
So what do they have in common? Despite all those differences, what's the one label, the one big category you'd instantly pop them both into?
Yep, they're both birds. And in the programming world, that idea, that shared category, actually has a name. We call it a class. So both the eagle and the hummingbird can be described as belonging to the bird class. And that's our first big idea.
Okay, so let's dig into that a little more. This idea of a class is the traditional, classic way of thinking about building things in code. It's often called the blueprint model, and you're about to see exactly why.
A class isn't the actual thing itself. It's the plan for the thing. It's like an architect's blueprint for a house, or maybe a recipe for a cake. The class defines all the properties and abilities that an object should have, but it isn't the object itself.
And this is a really, really important distinction. You have one class, the recipe, but you can use it to create a whole bunch of objects, which are the actual cakes. Each individual cake is a real concrete thing, or what programmers call an instance of that class. You can't eat the recipe, right? But you can definitely eat the cakes.
So what does this actually look like in code? Well, if you were using a language like C++ or Java, your instructions would be super clear. You'd tell the computer, hey, go grab that person blueprint and build me a brand new object, and let's call him Bob. It's a very structured, top-down kind of approach.
Okay, this all makes sense, right? It's super organized, but, and this is where it gets really interesting, one of the most popular programming languages on the entire planet, the language that powers pretty much the whole interactive web, decides to just throw that whole rulebook out the window.
So here it is, the big twist. Turns out, in JavaScript, there really aren't any classes in that traditional blueprint kind of way. It just gets rid of the abstract plan altogether. In JavaScript's world, everything starts out as a real, concrete object.
Which, brings up a pretty big question, right? If you don't have any blueprints, no recipes, how on earth do you build anything new? How does JavaScript manage to build a world without a master plan for every type of thing?
Well, the answer is a completely different way of thinking. It's called the prototype. Instead of designing from some abstract plan, the philosophy here is way more direct. Just build from what you already have. It's less about being an architect and more about being a really good photocopier.
So here's the key idea. You don't need some abstract person blueprint. Nope. All you need is another person who already exists. You just find one fully formed object that's already there, and you point to it and say, that's the model, the prototype, for any new ones I want to make.
Okay, let's use a great analogy to make this super clear. Instead of starting with an abstract person class, you start with a real existing object, let's say Bob's dad. You then tell the program, see this guy? Use him as the prototype to make me a new one, and poof, out comes Bob. You're literally creating new objects by just making a copy of an existing one. So we've just walked through two totally different ways of looking at how to create things. One is all about abstract plans, the other is about concrete examples. Let's put them side by side so it's impossible to miss the difference.
And this table just lays it all out. On one side, you've got the classic way. The request is all about building from an abstract idea, the class called person. But on the other side, with the prototype model, the request is to just reuse a real concrete thing, the object called Bob's dad. And that is the absolute core difference. Abstract blueprint versus concrete object.
All right, so if there's one thing you take away from all this, let it be this.
The classical approach, the one you see in languages like Java and C++, builds from abstract blueprints called classes. But the prototypical approach, which is the absolute heart of JavaScript, works by copying existing concrete objects that we call prototypes.
And that kind of leaves us with a really fascinating thought to chew on. The very foundation of our modern web is built on this idea of copying and tweaking what's already there, not creating something brand new from an original blueprint. So what does that say about the nature of creation and originality in the digital world? Something to think about for sure.